We are the shoe insole wear and comfort study group for our MEA 401 test engineering class. To provide some background for our project, we are testing TreadLabs insoles, which were supplied by Mark Pagan and our partners at TreadLabs who offered to sponsor our ME 401 project. This project will evaluate the comfort, usability, and performance of the insoles, where we talk about a study that we completed with human participants and also some mechanical testing on the insoles, which we'll explain later in the slides. For the human subject comfort testing portion of our project, all group members were required to complete city training for testing with human participants. These human participants would be subject to a 21-day trial period where they would wear the carbon fiber insoles every day. They would record their activities, whether it's going to the gym or playing sports or simply just walking around, and they would rate the comfort 1 through 10 for each activity.
So we had two main mechanical test procedures. First was looking at the insole arch height or the deflection over the period of use. And so we marked a point on the very inside top surface of the insole for each of the insoles and then measured their height, the height of the arch from a flat surface using a set of vernier calipers. Care was given to make sure that the calipers were perfectly perpendicular with that flat surface to ensure repeatable results. The other aspect was a 3-point bending test where we used a custom compression device to compress or bend the insoles through the center of pressure. And so here at the bottom of the slide, you can see a 3D scan that was basically used in order to make this compression device. And we're going to talk about that on the next slide. So as mentioned in the previous slide, we custom made a part in order to compress the insoles through the center of pressure. So we used a 3D scanner, scanned one of the insoles, and then imported this file, into SolidWorks, and we're able to convert that top surface of the scan into the top surface of this part here. And so you can see on the left, on the bottom, is a solid model of this part. So basically, we just had a block with the exact, mold of the surface of the top of the insole. And so using this, we were able to connect it into the materials tester and then deflect each of the insoles to a specific, height or deflection, and then measure the force required to do this. And so you can see here we have two different designs, first of which was using simple screw into the bottom. However, we ended up using a second design, the figure on the far right, that has a kind of hex bolt cutout in it that we were able to attach to the to our materials tester. It ended up being based on the availability of the supplies we had. So we weren't able to find a bolt that did not have a head on it. So we used a bolt with a hex head and then compressed it fully into this part to ensure that any deflection that we're measuring is based on deflection of the insoles and not deflection of the bolt or pressing the bolt further into this part. So these were 3D printed using 100% density resin, which was very solid, using a Form 3 SLA 3D printer in the makerspace.
Now for our bend test setup. On the right, you can see the setup we used. We had 2 rails that we found in the lab. We clamped these down to the load frame to make sure that the insole could move laterally. And then we pressed down on the center of pressure with our 3D printed resin piece. And from there, we were able to test the deflection at 5 to 1 millimeter. Here is the specific equipment that we used. In the top right, you can see our 3D printed resin fixture. On the right are some of the clamps that we used, and then on the previous slide was the load frame that we used.
For the safety risk assessment for our project, this project was deemed to be minimal risk by the IRB submission. All the participants were wearing insoles, so none of them had to put anything on the line. For the testing with our load frame, as in the picture to the right, you could see we were all wearing protective equipment, glasses, goggles, and coats, because we didn't know how carbon fiber could splinter. And we also only operated in 1 to 5 millimeters as recommended by Mark Pagan, just to be sure that we didn't break the carbon fiber and damage anything. So on this slide, we have the results for our deflection testing. So before and after the insoles were used, we used a veneer caliper to take the max arch height on each of the insoles. And after the 3-week period of wearing, you could see in the table that not much deflection happened as we expected. Carbon fiber is a pretty strong material. But the only thing we did notice is that human error was a major factor. The veneer calipers are accurate, but they weren't very accurate for our purpose. Maybe we could have taken a better crack at it with a different method. But overall, the arch heights did not change that much over the 3-week period.
So along with the deflection testing, we also performed bending testing on both sides of the insoles. We noticed there was a variation in the different sizes. For example, the smaller size deflected more in proportion to over a height, therefore required more force to bend it. And also there's a little variation between the used and unsold insoles, as we can see on the next slide. So like I said here, both these graphs demonstrate the different force required for the unused and used insoles on the left with the left insole and right with the right. And the green is what it is when it was used. Therefore, we can see it takes less force to deflect because they're already worn a little bit. And the red requires more force to deflect these insoles.
The group found that the male participants enjoyed the insoles throughout the comfort study. It should be noted that the insoles do have a 1 to 2 week break-in period, which was a large time part of our study, unfortunately. Overall, there was some mild discomfort for almost all members in the beginning. However, for our male members, this did pan out over time and became comfortable or preferred by many of our participants. However, our female participants were not satisfied with the comfort of the insoles and would not want to continue wearing them and experience discomfort when wearing them during the study. This discomfort could be attributed to the fact of mismatching the proper arch height. All of the insoles that we used in the study were a high arch height insole, where there's a high, medium, and low arch heights available from Tread Labs. So it's possible that the each participant's foot didn't fit with the high arch height, and then having different periods of break-in per user, just depending on individual preferences and use time, that could be attributed to the discomfort over the entire study. The major roadblocks for our group, the main roadblock was the submitting the IRB proposal to our institutional review board. That took a lot of time and reviewing. It took away from the length of our study, just since this study had to be conducted within the bounds of one semester. We would have liked for our trial to run for a little bit longer period, but just getting the IRB in approved and being able to actually have human participants within our study, it just took a lot more time in the semester than we would have liked it to. We also had to complete some training, which took some time just to get through kind of the red tape of that, just getting it done, getting it approved, and getting checked off before we could get our IRB approved. And then another roadblock that we faced was trying to find a way to best distribute the pressure from the load frame onto the surface of the insole, since the insoles have like a unique custom geometry to each of them, and there's not really like any like linear or flat surfaces that we could apply the pressure to. We needed to make that fixture and make it fit nicely around the center of pressure of each of the insoles. So that took a lot of time in making that fit and work for all the insoles, since we also did have insoles of different sizes. So making that geometry applicable to all the sizes was also a roadblock that we faced.
Overall, the results of the comfort study over the duration of the semester can be summarized as follows. Male participants were able to enjoy the arch support with minimal break-in time and minimal discomfort. However, the female participants recorded very low comfort ratings and would not wear the insoles again. The results of the mechanical testing show that the insoles themselves had minimal deflection and showed minimal wear over the test period. These results were expected because of the strong warranty of the product. However, the testing did prove that the use of the product definitely impacts the force required to bend the arch. So overall, we would definitely recommend doing a larger test period in the future to gain better results, specifically within the comfort study portion of the testing. Our results met our base hypothesis that insoles would show very little minimal wear over the short time, but bending force did vary depending on different factors such as weight and shoe size.